Hello and welcome to this section of the course. In this chapter, we'll be learning about binomial expansion, in particular advanced binomial expansion. I say advanced because things or questions will be rather different to what you already know and what you've learned in in previous years. In year 12, we learned how to expand simple powers of uh, brackets where value of n was a positive integer. That is, this power of n was always a positive integer. But in this section, we'll look at questions where n is either a negative value or a fraction, or n may be both a negative sign fraction. So, as always, I encourage you to have a go at the binomial expansion prior knowledge check, and then uh, I'll show you the answers in a few seconds. So pause the video and have a go, and then compare your answers with me. Alright, I hope you've had a go at this. Let's see what you would do for expanding 1a. It wants you to go up to powers of x to the power of 3. So you would have 1 raised to the power of 7, and that would be the first term. That would be simply 1. Then you would have 1 raised to the power of 6 and 5x raised to the power of 1. And don't forget the binomial coefficient here, which would be 7 choose 1. I left out the binomial coefficient from the first term because 7 choose 0 is simply 1. Now, the next binomial coefficient would be 7 choose 2. And we'll have 1 raised to the power of 5, but 1 raised to any power is still 1. And then we'll have 5x raised to the power of 2. And then we will have 7 choose 3, 5x raised to the power of 3. So we know that 7 choose 1 is 7. So we'll have 7 times 5x. Here we'll have a 1. Then here 7 choose 2. How do we do it without a calculator? We write 7 to the power 7 factorial over 2 factorial over 5 factorial. I know that 7 factorial is 7 times 6 times 5 factorial. I can cancel 5 factorial with 5 factorial. 42 over 2 is 21. And 5 squared is 25. So this would be my third term. 7 choose 3. I'm simply going to use a calculator. 7 choose 3 is 35. And we know 5 to the power of 3 is 125. And we'll have x cubed. So when you multiply out these numbers with each other, you end up with this answer here. For the next question, you start with 5 raised to the power of 10. Then you'll have to use binomial coefficient here. 10 choose 1 is 10. 5 raised to the power of 9. Negative 2x raised to the power of 1. And then we'll have 10 choose 2. Notice these are not vectors. This means 10 choose 2. You need to find this bottom on your calculator to find the answer there. Then we multiply that 5 raised to the power of 8 and negative 2 squared. Notice the powers here add up to 10. Each term, the powers will have to add up to 10. Finally, we need the fourth term. So that would be 10 choose 3, 5 raised to the power of 7, and negative 2x raised to the power of 3. So this would be a 10, and if you put the rest in your calculator, you should end up with these answers here. Now, if you remember from what you learned in year 12, I would always suggest leaving 1 minus x alone. And, well, actually, I would make a table here, 1 and x. And then once I've found the binomial coefficients of this term, the second term, the expansion here, I would put them on top of this table and then multiply things out. So let's just focus on what's the expansion of x plus 2 raised to the power of 6. So we'll have 2 raised to the power of 6, and then 2 raised to the power of 5. Not forgetting the binomial coefficient, 6 choose 1, and x raised to the power of 1. Then it's best to write the binomial coefficient first, and then 2 raised to the power of 4 and x squared. And finally, 6 choose 3, 2 raised to the power of 3, x raised to the power of 3. Because we want to go up to x cubed, yes, we don't need to write any other terms. So 2 raised to the power of 6 is 64, 2 raised to the power of 32, power of 5 is 32, 32 times by 6, x, and 6 choose 2 is 15, 15 times 16, x squared plus 6 choose 3 is 20, so we'll have 20 times 8 x cubed. So here 32 times 6 is 192, 15 times 6 is 240, and this term would give us 160. So I would write on this table of, this is a multiplication table, so we would have 64, 192x, not forgetting the signs here. Then we will have 240 x squared, and finally 160 x cubed. So multiplying those by 1 will not change them. This is a logical way of organizing my writing, because I know it will get messy if especially this number is 1, but in most cases these numbers are not straightforward, so multiplication needs to be done carefully. So here we'll have 64x, here we'll have 192x squared, and here we would have 240x cubed, and here we would have 160x raised to the power of 4. Now you must add the coefficients of these two terms together because the powers of x match, and you would add the coefficients of these two with each other because the powers of x match, and you would add these coefficients with each other. When you do that, you end up with this expression here. Now obviously I've messed up here because there should be a minus x here, so there should be a minus sign, which I'll put in with a different color. So that's a negative, that's a negative, and that's a negative. So actually this last term doesn't matter because we don't use it for the powers of 4, but still. Okay, so when we add these two terms together, we'll end up with negative 80 x cubed. When we add these two terms together, negative 192 plus 240, you'll end up with 48, positive 48, and 192x minus 64x would have given you 128x. Okay, as I said, I find the pattern of I find using this table much easier because it keeps things neat and tidy. Alright, I'm gonna get rid of my handwriting. If you like to pause the video and compare your answers, I'm gonna see you in the next. So, okay, I'm not gonna go through the working out for question 2. I've explained it in detail when we went through chapter 1, algebraic fractions and partial fractions. So this would involve you working out some partial fractions. The last part, 2c, involves you doing algebraic division as well. So I'll I'll show you the answers and then you can compare your answers here. So I'll see you in the next video.